Let's examine the effects of losing the PVC between R2 and R3. We have simulated this by removing the static frame relay maps between them and reloading all the routers. First, let's check R1. Note that R1 sees R3 as the DR, but it sees R2 as DR other, not BDR. Let's check the routes. We see that R1 has a route to the loopback on R3, but not the loopback on R2. Let's check R2's adjacencies. R2 has an adjacency with R1, and it sees it as a BDR. The adjacency with R3 is down. Now let's check the OSPF interface on R2. Note that R2 sees itself as the designated router for the link. Also note it has only a single neighbor, R1. Since R2 and R3 cannot talk to each other, they both think that they are the DR. With the PVC down between R2 and R3, they will have to communicate through R1. We will add static maps through R1 to both R2 and R3 and see if that fixes anything. First, we'll add a map to R3 through R1 from R2. And now we'll go to R3 and do the same back to R2. We see that R2 and R3 can communicate via unicast. Let's check the adjacencies. Note that we have a good adjacency with R1, but the adjacency with R2 is still down, because R2 and R3 cannot become adjacent. This is because the time to live field in the IP header of all the OSPF hellos is 1. As we know, the hub decrements the TTL when it routes packets from one PVC to another, so R2 and R3 cannot become adjacent. Let's see how this lack of adjacency and DR confusion affects the routing tables. Again, R3 has R1's loopback, but not R2's. Now let's check R1. Note that R1 has R3's loopback, but it doesn't have R2's loopback either. Let's go down to R2. Note that R2 has learned no routes at all via OSPF. To explain this behavior, we need to look into the OSPF database. Here's the OSPF database on R2. Note that R2 has a full complement of router LSAs, one router LSA from each router in the area. But there are two network LSAs, one sourced by R2 and the other sourced by R3, indicating two DRs on this subnet. Let's take a look at them. Note the network LSA sourced by R2 does not list R3 as a router on the shared link. This is because only routers that are fully adjacent with the DR are listed on the network LSA. Also notice that the network LSA sourced by R3 does not list R2. Let's take a look at the router LSA that R2 got from R3 via R1. Note something very important here. The first line in this LSA says, advertising router is not reachable. This means that R2 does not know how to get to this router. OSPF cannot use the routes in a router LSA if it does not know how to get to that router. That is why 172.16.1030 is not in the forwarding table, even though it's in the database. To fix this, we need to make sure that all routers become adjacent to DR. That means all routers must have a direct PVC with the DR, and only R1, the hub, qualifies. To make sure R1 is the hub, we will make the spokes ineligible to be elected DR by making them priority 0. Now we'll do the same on R3. After waiting a few minutes for the adjacencies to clear, we'll check them out. Let's start on R2. R2 now sees R1 as a designated router. It does not have an adjacency with R3, but it doesn't need one here. Let's check the routes. We see that now R2 has full routes, the loopback from R3 and the loopback from R1. Let's check R1. Note R1 is adjacent with the other routers on the subnet. As we have seen, if there's a designated router, it must be adjacent with every router on the subnet. For this to happen on a frame relay hub and spoke, the DR must be the hub. This is true of both the NBMA and broadcast network types. NBMA and broadcast network types can be made to work on frame relay hub and spoke topology, but the point-to-multipoint network type was made for it. As we have seen in earlier presentations, frame relay is a point-to-point technology. Each PVC is its own broadcast domain. The point-to-multipoint OSPF network type models it as a collection of point-to-point links, rather than as one big shared subnet. The point-to-multipoint OSPF network type has no need for a designated router. It treats each link as comprising just 2 routers, so there will be no network LSA. It can be configured with or without the non-broadcast keyword. Without it, the hellos are multicast. With it, they are unicast. To configure it here, we will just change the network type on each interface on the 123.0 subnet. Since we already have our neighbor statements configured, we will use the non-broadcast feature. First, we'll do R1. Next, we'll go to R2. And finally, R3. Now let's go back to R1 and check out the OSPF database with the point-to-multipoint network type.